Okay, questions? So we've been doing threads, and we've learned how to create threads. We still have to figure out how to harness threads, and that we'll come back to later, because I want to do something relevant to your next project, next assignment. And we're going to introduce the next topic. So we'll go back to inheritance, come up with an example, and that example we'll carry forward in a way that will help your next assignment. Okay. So we're going to do another application, and this is an application that lets a student who's at a university figure out if there's a course being offered in their area of interest. Okay, so they'll enter a course title, and the program will say either that, sorry, this title is not offered, this subject is not offered, or it will say, here's the course number. Okay. And the UNC numbering scheme has changed in the last 5 years or so. And this example I created before the numbering scheme changed. And I'm going to use the old numbering scheme. So this is based on what used to be the UNC numbering scheme. And the reason I didn't change the example, I didn't change things is because my example won't work with the new numbering scheme. Okay. And I use this example in many, I carry this example further in many contexts. It's going to be a little different from what you're used to. So at one time, 401 used to be called Comp 114. In fact, most of us in the faculty still think of it as 114. The course that used to be called 114 is 401. And 110 used to be called 14. And so so, if you want to, so here we have the students saying, I want to know whether there's a course on intro programming. If they go and mention the title correctly and enter the title exactly, okay, then they'll say, okay, that's Comp 14, okay, the old Comp 14. And then you have these numbers that are repeated. And can anyone guess what kind of courses these numbers are? Freshman seminars, right. And at one time, all of them had the same number, and now they're different, right? So that's part of the reason for changing things. Okay, I really need these freshman seminars to be the same number in my example. Okay, and so if the course doesn't exist, it says, sorry, it doesn't exist, and so forth. Okay, so you guys understand what this program is doing? Okay. Okay. Now, how would you create a set of classes? Okay, you've created many, many classes by now. And what kind of classes might you create to implement this program?
Something that takes user input, something that makes sure it's in the correct basic format, like instructions or whatever, whatnot.
Okay, so let's see how intelligent this program is. This thing here, you think it, you're being very, you're being much more sophisticated than this program is. So this is going to be just any string. Okay, so it's not going to check that this is a string or not. And notice this is all that the user is entering, right? The user is just entering these strings. The user is not entering any number here. We will carry this example further and have numbers also input, and that's when things will get complicated. But for now, all they're entering is a string. So in terms of checking, the program is just going to look at that string and see if something existing.
Use a table.
So you could use a table. Now that you guys know table, you know that that table could be a key. Okay, and what would be the kind of values stored in the table? Class names. Okay, so maybe it's more than one string. Maybe it's an object that has the name and the number. Okay, and then it becomes, then maybe the table is not the best data structure because we have the keys also be names, and we have the names stored in the courses also. So maybe we can do something more specialized here. Okay, Zach?
Why would you need the names to be stored as the key and then the courses? Why couldn't you just have the key be the course names?
So you're saying that in the course you don't put the key in there?
Yeah, the table would just be the key to the course name and the number.
Okay, so that's something you could do.
Like if say they have an intro program and that's something the table can print their input and then COM14.
Yeah. So in this example, you could do exactly what you're saying. Okay, you could have the table have the keys be the names and the courses be things without names. Okay, but in general, we might want to look at the course on its own without it being in a table, and we might want to print it somewhere. So we don't want to go back to the table and say, by the way, which key matches this course to find out its name. Okay, and we might build a hierarchical structure where we have course lists which have courses in them, which are course lists in them. So we could, but for this particular example, that would work just fine. Okay. Now, somehow I said that, look, I needed all freshman seminars to be the same number. So, your solutions, where you say every course has a course number and a name, doesn't take into account the fact that all freshman seminars have the same number. So what kind of optimization could I do to take into account that all freshman seminars have the same number?
Just in a table, if you have it organized by the name, then the course numbers could be repeated because that's how the sort of table.
So you're saying that for all the freshman seminars, the course numbers would be repeated if every course is storing that number. So then, but in the case of, I have the following choices. So I have some kind of course list that stores courses and matches titles. Okay, we'll come to that later. Okay, that will become a center of attention later. We have some main class that creates course list and adds course instances to it. Somehow these courses were filled. Okay, right now they're filled. Later I'll develop the example where we will actually enter these courses interactively. Okay, that's when we'll get into this parsing, which is the next thing we want to look at. Somehow we are printing courses. And the issue is, what kind of course classes do we have? Do we have one course class or multiple course classes? So what do you think, based on the fact that we want to optimize for one kind of course and store the number for another kind of course, we should have how many classes? At least two. So I could go and have either just one course class, and its properties would be, I'm just storing the name as title and department. Okay, I really didn't need to do it. I just did it. I think in some future example I might use this. So I'm separating the department and the title, but we have the number. And I could have these three properties exist in both freshman seminars and regular courses, for sure. Okay, when we print them out, we want all three things. The question is, which of these properties are stored and which are computed? Okay, and in the case of, and since we are going to have only one course class, and since a regular course does require a number to be stored, we are going to have three variables also for title, department, and number. Okay, and that we realized is not very efficient when our course is a freshman seminar. Okay, so we don't do so. The other alternative is, or another alternative is, so this is not appropriate for freshman seminar numbers. So we could have two course classes. They all have the same interface, so the same properties. And in the case of a regular course, I do indeed have these three variables. But in the case of freshman seminar, my title and department are two variables, and my number is a named constant. Okay, and named constant is something that is just created once for all instances of that class. Okay, so it's not a variable that you store in each class.
So because it's a constant, Java only even if you've got 100 instances of it, Java only allocates one memory location?
Yes, if you have a constant called freshman course number declared, it's just going to create one value because that makes sense, right? It used to create multiple values, okay? And whether you set public static or public without static, whether you set static or not static determined whether the value was duplicated or not. And I always found that silly. But they said, look, why don't you just use static? And then I kept testing Java out, and one of the versions I noticed that there was only one. They stopped doing it. Okay. In fact, if you have the number 100 5 times in your program, Java is going to only create one memory location for 100. Okay. So it does try to do. Most compilers do that, and Java is doing that also. Okay. So I can either have one course, or I can have 2 courses. And now if I have 2 courses, I'm efficient in terms of memory, but in terms of how much code I had to write, am I duplicating things? So these variables are duplicated, and the properties based on them are also duplicated. So how could I have the efficiency and the modularity and the reusability? Inherit. Okay, we all know that. So that seems like that's a pre-midterm exam question, right? But some variable. So I went too quickly. How is this class going to be different from the classes you created before that were inherited? Zach?
You have a pointless class, not pointless, but a non-used class. It just sits there to hold code essentially.
So you have a class that is used. It is used by subclasses.
It's not used directly itself.
It's not used directly itself in terms of being instantiated. Okay?
Well, I don't.
You took, so should not be instantiated. I'm amazed sometimes how quickly you guys can follow this stuff, which is good because I don't write code. I present code to you, so I'm happy that some of you can actually read the code very quickly. But I do try to slow down. You cannot have a course without a number. Okay, so this class doesn't make semantic sense on its own. Yes, it's got this code that is to be inherited, but it just doesn't make sense semantically. Okay, so this is a class that we'll call an abstract class. Okay, it's not an instantiated class. It's not a concrete class that way. It's not used to create concrete instances. And in terms of our inheritance hierarchy, when we talked of human beings being organized into classes and cars being organized into classes, so you don't say, I want a car. You go and say, I want this specific kind of car. And once you've got a bunch of specific cars, we say car, the abstract class car unites these cars at concrete classes. Okay? So similarly, a chimpanzee is born, not a mammal. Right? Mammal is just something that organizes a bunch of species. So this is, car versus Honda Accord, mammal versus, and look what we did this time. Why this inheritance task was a little different from before. Before we were being very opportunistic. We had a string history. Suddenly we had a need for a string database, and we said, oh, we already have a string history. Let's inherit. Okay? And similarly, Java comes up with a bunch of classes, and you might want to extend the behavior, and you say, oh, I've already got this class list, and I'll go and this array list, and I'll inherit. Okay, that's somewhat easy when we talk of decomposing a program into classes. Here we went and did, we went and then needed a string set, and we extended a string database. Now we're not being opportunistic. We're really thinking hard. And before we started the problem, before we created any the subclasses, we created the superclass. That's top-down thinking, right? That's you're looking at the problem and seeing what kind of things you need based on that. And that's what everybody will recommend to you. A lot of textbooks will say, don't do this hacking-based bottom-up programming. Do this top-down programming where you think of the problem and before you code, you give a lot of thought to it. Okay? And in your projects, you guys have been doing bottom-up or top-down programming? Bottom-up, right? I give you assignment 1, I say transform that into something else, transform that into something else. You guys are doing bottom-up. Maybe someone else did top-down thinking before that, right? So I had a plan, somewhat. Okay, and in general, I can say do top-down thinking, but we guys. How can you test it with top-down thinking? So you build skeletons, you do a lot of things, you build stub procedures which don't do anything but say for future, or you create all your interfaces first, then you can create your classes later. So it is possible to do that. Okay, and look what we did here. We filled in this code first, and you're saying, okay, if the first assignment was an abstract class, there was nothing to instantiate, right? And that's partly true. Okay, so the idea is that you don't test till much later. Okay, and if you do test early, then you build stubs in, right, which do nothing and are to be filled in later. Okay, so there's something called test first, which I don't know whether I talked about in this class or not, but that is that you just build stubs in. Okay.
What I meant was, how would you, not like me as a programmer, how would you, the teacher, tell if we were programming?
And they're the same question, right? If you can test your code, I can test your code too. In fact, ideally, if we guys could get really organized, and if I didn't change the course from class to class, I would give you guys a grading program, okay? And you would run it, and you would see what issues it creates, and then you would only give to us what has been graded. But our test cases tend to be done like the night before grading is done. Okay, our grading program is written. So we're all deadline driven. You are, I am, the TAs are. Okay, but anyway, I've shown you what top-down thinking could look like. At least in this problem, it was not such a difficult thing. Okay, and I think most practitioners say there's a mix of top-down and bottom-up, and they call it middle across or something. I forget what the term is. Okay, so you could, but it's really a combination. People often talk about, when I studied this, I had to walk 10 miles in the snow and so forth compared to you guys. So I was an engineer, and I studied Fortran, and I actually used punch cards. And you couldn't afford to make mistakes there because the run took a while. And so that was a lot of top-down thinking. You just debugged and on the code, you didn't try to just run it and see what happens. So there are these old people who go and talk about top-down thinking because they did really do it. Today, you've got these interactive computers, and you can do a combination of both. Okay. It's an abstract class, and you tell Java it's not to be instantiated by accident. Okay, because somebody might do so and create something semantically that's not meaningful. So you tell Java, look, it's an abstract class, and you put the keyword abstract. Okay, that's it. Okay, and in your project, you can well figure out that there are many classes that need to be abstract, and your next assignment will tell you to go and make those classes abstract. Okay.
So what exactly does the abstract kind of tell Java?
It tells Java, if anyone does new a course, tell them, sorry, this is an abstract class, new is prohibited.
Okay.
That's it. That's the only thing it tells Java. It tells the reader that, look, look for its uses, because this is not a complete unit, it's something just to be used. It's a skeleton. Okay?
Sometimes when I type in a new class and I say that it implements some interface that I've already typed, but I haven't in the class given it all the methods in the interface, it says either implement these methods or make this class abstract.
And so what James is saying is that when you have not implemented all the methods in an interface, Java complains, and it says either you should implement these methods or you should make them you should make this class abstract. Okay, and if you can just hold that question for about 3 slides or 4 slides, we'll come back to it. Okay, but notice that I did not, and it has to do with the fact. So I don't go and say, by the way, that this class implements interface. Am I being bad here? I've so far told you that every class must implement an interface. So I'm not saying this here, and am I being bad?
Aren't interfaces like an abstract representation of like a class?
So you're saying an interface is an abstract representation of a class using the English word abstract. An abstract class is also an abstract representation of a class using the English word abstract. But different kinds of abstractions, right? In one case, I'm saying these are the method headers. And in that kind of abstraction, I increase your headaches when you, as a class implementer, have to implement an interface. You have to implement them. Here again, when I talked about inheritance, here you're inheriting from this. Here I'm reducing my headache as a thing. So yes and no. Okay, it's not quite the same kind of abstraction.
Wouldn't it be easier though, since the SO classes will have to implement an interface? You could have that interface inherit from.
Okay. So first to answer, am I being bad here? What is my rule now? It's confusing, right? My rule so far was that if you've got every public method should be in an interface, okay? And this public method doesn't seem to be in an interface. So I seem to have broken the rule here. And I'm going to say it's okay to break the rule here. Even if and you're telling me that why it's good to actually say implements interface, okay? We'll come to that in a minute. But I'm saying it's okay to break the rule here because so by the time this particular class gets used, it will be a superclass of a concrete class, and there we will have our rule. So when you actually have an object of that type, you will have an interface to type that object. Because the object will be a concrete object, which means there must be a concrete interface there. So for abstract classes, we can break this rule, even though Keenan is telling us that maybe we should have the rule even here, right?
When you're not going to ever call the methods from the abstract class itself, so you need an interface.
See, you call the methods from some user of the class. And you can actually have my getDepartment method call my getTitle method, if it somehow that makes sense. So you can call methods within there too. The issue really is when you're outside the class, because that's when the interface matters, right? The interface is what behavior I give to you. Internally, who knows what my interfaces are, and that's all public variables here. So that's when it comes out. So there is a confusion as to, what does it mean for an abstract class to implement an interface? Should it implement an interface? And I've got a few slides later. For now, my rule's okay, because I'll be typing concrete objects, which are instances of concrete classes. And as long as I have this rule for concrete classes, that every public method of a concrete class must be in some interface, inherited or not inherited, then I'm fine. Okay? And my regular course now extends a course, and it does have this rule. It implements course, okay? And some of the methods that it implements are inherited, Fred? Yeah, so that's what I'm just going to come to in the next. I didn't know which one to present first, and I knew I had to sort of do them together. So, but yes, let's just look at that, and let's look at what that really means. Okay. So for now, since we didn't have the abstract class say implements course, we have to do this here. Okay. My freshman seminar extends a course, and it uses seminar number. And it doesn't declare seminar number, but we know it's in capitals, it must be a constant. Seminar number was not declared in the abstract class, so where do you think it's declared? In the interface. Okay? That's why I don't implement course, I implement freshman seminar. Freshman seminar extends course and declares that constant. Okay? And it declares the constant. A constant could go in a class on an interface. If every implementation of the interface has to use the same number, then that constant should be in the in the interface. Otherwise, if the constant is very class specific, it is in the class. Okay? So here's my course. It's got the three properties. Here's my freshman seminar. It extends course and has the seminar number in it. Okay? And I didn't make it static. I don't need to. It's the same thing. I don't want to type extra. Okay? And the reason you would still sometimes make it static is that you can go and say from outside, supposing you make it public, it makes sense to make it static because then you can, from outside the class, say freshman seminar dot seminar number. Okay? which you can't say if you don't make it static, even though it will be stored only once. Okay? So that's the reason why people recommend static. And I could have done this now. Okay? And I could have said a course implements course, but course has a get number in it, and there is no get number method in here. So is this even legal? You guys have been itching to do this, but does this make sense?
Based off of what you said for how abstract classes don't have to directly implement interfaces, then yes, it does make sense because you'll never make an instance of just a course. So it doesn't need the methods there because it will be implemented later by a class.
Very good. Okay. So what Nathan just said was that it's okay to do this. Abstract class says, I'm just a skeleton. Okay. I'm just writing down all the because if I go and say implements course, all of my subclasses inherit the interfaces I implement. Right? So all I'm saying is this is an obligation of any subclass of mine. That's all I'm saying here. I'm not saying I'm complete. I'm just saying when I say implements this, it's not that I have methods that implement these bodies for these methods. I'm just writing down my obligations here and saying I'm incomplete. That's what the word abstract means. So when I'm completed, my subclasses will inherit these interfaces and they will have extra obligation. Okay, James?
If a subclass of a course, like a regular course, did not implement get number, would it get compile or run?
It will give you the error that you got. It will say either make a regular class abstract or implement that method.
Okay.
So that is exactly what it was saying. It was saying, when you got that message, it was saying, you don't want to implement this method header? Go and make it abstract. Somebody else will have to do it. Okay? Questions? That's abstract. And okay, I seem to have an extra slide there. And now my regular course can just say extends a course. It doesn't have to say implements course. The rule I gave you guys, it still works. Okay? Every method that it inherits or defines is in an interface it inherited. That's okay. Okay? So indeed, I did type less, and indeed it all worked out because an abstract class doesn't have to really implement its interfaces. Okay? Questions? Okay, and now we'll get into course list. Our course list is going to be something that stores all these courses. Okay? And it's also a course list that you can search. Okay? Now, we've already done a searchable collection before. Remember, we had a string history, then we had a string database and string set, and we had a member, and the member method said, is an instance of this particular list, is a particular object that is stored in the list, that could be stored in the list, actually in the list or not. I have to do searching here too, but the searching is a little different. How is the searching here different from the searching in a database or a set? Zach?
You were just looking, matching whatever the string database, you're just matching the strings. Whereas here, you're not matching objects, you're matching a property of the class.
Okay. So there you were storing a bunch of objects and you were saying, is the object that you're querying equal to the object that you're storing? Here saying, I'm giving you a property of the object that is stored, and I don't want a Boolean answer yes or no. I want the actual object that matches, if it exists. Right? So if interprogramming exists, I want the whole class object with the number also. Okay? So if it doesn't exist, what value should our search method give? Null. That's a common thing. Or what else were you thinking? Well, it's a function. Okay, and you know, the error message is something that the retriever is going to decide on. Okay? Okay? My course list is a storer of objects. It's got an add element. And it's got a match title method, which takes a property of that particular element it's storing and returns back the type of element stored. Okay, that's my. So you can see it's a little different from a table. I've got this kind of functionality. Okay. That now we can just go and see how it works. So the storing elements code is no different from what I've done before, and it's just I'm using an array. I could use an array list, but I don't want to make too many assumptions about what you know when you look at these slides. And the add element is not at all different from anything you've seen before. And the interesting part is the match title. And as you can imagine, it's just going through all the elements one by one, and it's checking if the title property of the element that's stored at a certain index equals the one that was given as a query. If it was equal, it returns the value at that index. Otherwise, it returns null. Exactly what I told you. Okay? This is, you guys have written much fancier loops than this. This is just that kind of thing. Okay? And my main method has first a method called fill courses that we're going to go and change in the next slide deck. For now, it just has some predefined courses filled in, okay, so that I can make my example work. And then it goes in a loop, and it goes and asks the user to go and enter the title. And I use, there's so many different versions of readline I have. I'm not even sure which one I'm using here. And or even if it's legal, actually. But it reads line somehow. And it checks if the line is a dot, in which case it breaks out. Otherwise, it says match the title from the courses. And if match course is null, it says, sorry, the course is not offered. Otherwise, it prints the header and prints the match course. Okay, so again, not an interesting loop, just for. And this is my course list here. And to the course list, I'm adding a bunch of courses. And this is the concrete instances being created. Okay, so when I instantiate regular course, a freshman seminar, and I'm not instantiating a course. Okay, example complete. Okay. And this is the stuff we're going to now, in the next slide deck, work a little bit more on. Questions? And here's, for completeness, the